So the way you do these are 8 less than 5 times the number. When it says the word less, you put it after the fact. So 5x minus 8, not 8 minus 5x. And 3 times the difference of 4 and a number, it's 3. And then times a difference. And that when you say difference, you put it in the order it appears. So those are a little bit squirrely. So just remember that you're multiplying 3 times the whole difference. So you have to use parentheses. Okay, so one of the ones I liked was the quotient of y and 3 is the same as, that means equal, the difference of 2 and the product of 2 and y. I want us here to solve for t. So the first thing I do is I look at the equation and kind of get a plan together before I start. Because sometimes you start and you start moving things around and you never get where you want to be. And I'm seeing t's on both sides of the equal sign and a number on the right side. So I'm going to move all the t's to the left side, and then I'm going to leave the number alone. Well, when I do that, I don't do what you guys do where you put a minus 2t on both sides. I just cross the bridge by going 3t minus 2t equals 5. This is a positive 2t. When it crosses the bridge, it turns to a negative 2t. So I just do it like that. If you want to do it your way, is fine.
You keep smudging.
Whatever. Quit touching it. And so now 3t minus 2t is t, and t equals 5, and that is your answer. Okay? Let's get a little bit harder now.
Do we have to? It's called simple equations. It shouldn't be that hard.
So this one here, there's one thing that's kind of annoying about this problem, and what is it?
The 5?
The 5. Very good. That 5 under there bothers me because you guys hate fractions. So what are we going to do to get rid of that 5?
Multiply everything by 5.
Multiply what?
Everything by 5.
No, just the fraction.
You have to multiply everything.
Remember we talked about the birthday party and the birthday cake? Did we talk about that in here? Everything gets a 5. Everything gets a 5. Yep.
So it would be negative 10a.
So it's 5a, nope, because this 5 is going to bite the dust with that one. So it's minus 2a equals 15. You see it? Those 5 bite the dust. That's what you did it for, to get rid of it. So it snuffs it out. So now we have 3a equals 15, a equals 5. So when we're doing this, we're leaving the p alone. You circle the line, the letter you want to leave alone, and then get rid of the letters that are near it, or anything that's near it, and leave the p alone. So we end up with p equals I to the RT, because we got rid of the RT by dividing. Okay? Here, you're going to circle the y.
Is that I next to it, or does it say I for
That's
y?
a semicolon.
Oh, okay.
You're going to circle the y, and the thing you have to get rid of the x and the 2. So which one are you going to get rid of first? The 2. You want to get rid of the 2 because he's the most annoying one first. Okay? You know how that is? So you have 2a equals, these will bite the dust, and you have an x plus y.
Sorry.
And then you circle the y, and now we're going to cross the bridge with the x, so we have 2a, and that's a plus x, so it turns into a minus x equals y. And we're done. The y is alone, and the answer has a's and x's in it. All right, so on these two terms, like Luke said, you can't combine them because the letters are not the same, right? But each one has a pi, and I want to give the pi alone. So what I'm going to do is I'm going to factor out the pi. Now look at that. If I multiply pi times 2r squared, don't I get 2 pi r squared? And if I multiply pi by 2rh, don't I get 2 pi rh?
Yeah.
So I can factor that out. Now who is with the pi? This mess, which is ugly. So I divide that by that and divide this by this. And I'm done. So a over 2r squared plus 2rh equals pi.
I didn't think at all to factor, right?